Okay, so some of you had this combustion question on your exam or on your quiz, which was combustion of a compound whose empirical formula we don't know. So it's CXH something O something. But we do know how much CO2 we collected and we know how much water we collected. So first thing we're going to do is use those numbers to figure out how many moles of carbon and hydrogen we have. So starting with the 1.6004 grams of carbon dioxide, we're going to go ahead and convert that to moles of CO2. And we know that there are 44.01 grams of CO2 per mole. And then we also know if we look at that formula to get moles of carbon, it is 1 mole of carbon for every 1 mole of CO2. And I'm going to go that far with this one to get my moles of carbon. And at this point, what I want you to notice is how many sig figs I'm using. My original measurement actually has 5 sig figs in it. So I find that the more sig figs I use that match that original measurement, the better my numbers come out. But I also know that law of conservation of mass means the number of grams of hydrogen and carbon I collected plus the grams of oxygen I have should mass out or add up to 0.8009. So I eventually want grams of carbon as well. So I'm going to go ahead and just calculate that now. I know that 1 mole of carbon has a mass of 12.01 grams, and so that is going to give me 0.43674 grams of carbon collected. I'm going to go ahead and do the same thing for water. I'm going to take the 0.6551 grams of water, convert that to moles of water, and that's 18.02 grams. What's different about this one, if I look at that formula, notice there are 2 moles of hydrogen for every 1 mole of water. And so that's the big difference between the CO2 and the H2O is that mole ratio of hydrogen, and that gives me 0.07271 moles of hydrogen. Same thing, I'm going to go ahead and convert that to grams, and because the molar mass of hydrogen is almost 1, I'm not going to see a big difference between grams and moles of hydrogen, but enough. It ends up being 0.07344 grams of hydrogen. Okay. So now let's focus on the oxygen. If I know my compound had a mass of 0.8009 grams, and that's of the entire compound, I'm going to subtract the mass of the carbon plus the mass of the hydrogen to just get the mass of oxygen. And so that gives me 0.29072 grams of oxygen. In order to figure out what my empirical formula is, though, I really need moles of oxygen. So you're not done at that point. You need to take your 0.29072 grams of oxygen and convert that to moles. And we know that there are 1 mole of oxygen for every 16.01 grams. All right. So at this point, we have 0.01817 moles of oxygen. Now we have all of the information we need right here for mole ratios to divide by the smallest number. And you'll notice that our smallest number here is definitely the oxygen. So we're going to go back and we're going to divide all of those by the lowest number, which is the 0.01817. So that is actually going to give us our mole ratio. So for oxygen, we know it's going to be 1. For hydrogen, if we divide that by 0.01817 moles, we end up getting, I believe, 4. It's pretty close to 4. And if we divide our carbon by 0.01817 moles, we end up getting pretty close to 2. And there's your empirical formula. So you're using a little bit of mole ratio, a little bit of law of conservation of mass, and they're all in there. There we go.